Hey guys, this is Akshay. So now you are back to my channel, which is Science with Sam. So now you want to do the next video, which is nothing but the functional groups and the other properties of functional groups. So yeah, as I said, now we'll be doing the properties of the functional groups, and apart from the properties of functional groups, we'll also be doing the details of homologous series. So the first property of functional group, which is given here as I've written on the board, it says that the chemical and the physical properties of the different functional groups will be different for depending on the functional group. It will differ, which is the chemical as well as the physical properties will differ depending on the functional group. So from this fact you will come to know that, for example, if you have a compound like CH3COOH and CH3OH, so these two are two different compounds which has two different functional groups, which is COOH is a functional group which is known as carboxylic acid, and this functional group is known as OH, or an alcoholic functional group. So when both the functional groups react with the same compound, which is known as PCl3, so PCl3 is known as phosphorus trichloride. So when both the functional group reacts with the same compound PCl3, the products, the major product will be different for both. So this fact will tell you that the chemical properties of different compounds having different functional groups will be completely different. So now just let's write the reaction without balancing the equation. Just the major product will be written, so you will know the difference of the chemical property. So yeah, so first is CH3COOH. So here when you write the product is known as an acetyl chloride or CH3COCl. So in the last part of your organic chemistry in the 10th standard textbook, you will be doing the properties, chemical properties of carboxylic acids. In that you will come across the word acetyl chloride. So it is ACETYL, which is acetyl chloride. So yeah, that is the major product of the first reaction. So now the second reaction says CH3OH plus PCl3. CH3OH plus PCl3 will actually give you CH3Cl. CH3Cl is the usual metal chloride. So the metal chloride, the name is nothing but a general name for the compound. So this is how we come to know that the chemical properties of different functional groups will be different, because the major products are different. So the next one says the physical properties of different functional groups will also be different. So what do I mean by a physical property of a compound? Physical property of a compound means either the mass, the density, the melting point, or the boiling point. So these four factors will be different for different compounds depending on their functional group. So the mass will obviously be different, so therefore the density also will be different. So why do I say so? Because you take this compound CH3COOH, the functional group is COOH. There is an extra carbon, extra oxygen compared to this compound, which is CH3OH. So automatically the mass will differ. And next, because density is nothing but mass by volume, you take equal volume of CH3COOH and equal volume of CH3OH, the density will be different. The reason for this fact is that the molecular mass will be different. So the next one says the melting point and boiling point will also be different. So for melting point and boiling point, there's something, the bonding is very important. I would have mentioned in the first video that the melting point and boiling point of ionic compounds will be more than the organic compounds because of the intermolecular or the electrostatic force of attraction. Electrostatic force of attraction is a better word to use other than any other terms which are used in a textbook. Apart from that, there's one more type of bonding which you will be doing in detail in the chemical bonding chapter, which is known as intermolecular hydrogen bonding. The intermolecular hydrogen bonding is generally with hydrogen and highly electronegative elements. Again, the electronegativity, the term electronegativity will be dealt in detail in the periodic table chapter, but those are the basics. So I'm sure you will be knowing about all that. So the bond formed between hydrogen and a highly electronegative substance is known as intermolecular hydrogen bonding. The intermolecular hydrogen bonding in CH3OH is very high, that the melting point and the boiling point of CH3OH will be higher than CH3COOH. So from this fact we come to know that the physical properties will also be different for different functional groups. Chemical properties will also be different for different functional groups. So this is the first fact. The second fact says that method of identification of a functional group will be different for different functional groups. Like for instance, to identify that a compound has a certain functional group, let it be X or Y, there's a chemical test for it. Like in the actually after this, the next part says alkanes, next part is alkenes. Like you have around 5 to 6 parts. In every part of the chapter, you'll be having a subdivision which says chemical properties, and then a subdivision which says method of testing whether the compound has an alcohol group or a carboxylic acid group. So the method of testing for a functional group is always different for different functional groups. Like for instance, you have a CH3COOH. To identify the COOH is the functional group present, you add a compound known as neutral FeCl3. So neutral FeCl3 is ferric chloride. So here the valency of iron is 3. So you can also call this iron 3 chloride. Because your textbook, in the end of the chapter, your textbook will actually use the word iron 3 chloride. Why is it 3? Because it's FeCl3 and the valency or the charge possessed by iron is 3. That's why you use the word iron 3 chloride or ferric chloride. When you add ferric chloride to CH3COOH, you will be getting a red wine color. And this red wine color is not obtained when you add an aldehyde, when you add an alcohol, when you add an alkene or an alkyne. So this is what I mean by the fact that method of identification of different functional groups will always be different. So the next one which says homologous series do exist. Now in the next video I'll be doing homologous series in detail. So what do you mean by an homologous series? A homologous series is generally where the first substance of the whole series and the second substance of the whole series will have a difference of a CH2. So it will have a difference of CH2. So what do I mean by this? So let's take a very simple example of an alkane homologous series. So an alkane homologous series, you take the first element as CH4. So now the second element is, which is nothing but a second compound, is C2H6. So we know that the first compound of the alkane series is methane and the second compound is ethane. So let's check the difference between the number of carbon atoms and hydrogen atoms. So here is 1 and 2. So there's only a difference of 1 carbon atom, and there are 4 hydrogen atoms, and here it becomes 6 hydrogen atoms. So it becomes CH2. So this is an example of a basic homologous series. But since we are going to talk about this in terms of functional groups, so let us talk about homologous series with respect to a functional group. So CH3OH is nothing but a methyl alcohol. One hydrogen has been replaced by the OH group, and then the next homologue of this homologue is nothing but the subsequent compound of the homologous series will be C2H5OH. That means C2H6 is ethane. One hydrogen of ethane has been replaced by OH group. So now let's just check whether this difference of CH2 group is applicable here. 1 carbon, here's 2 carbons. 1 carbon difference is there, and here 3 carbons, 3 hydrogen, 3 plus 1, 4 hydrogen atoms are here. Here 5 plus 1, 6 hydrogen atoms are there. So 4 and 6, the difference is 2. So even in this, the homologous series do exist. And then apart from that, the homologous series do exist in the case of an alkane or an alkene, even an alkyne also. So